Hey everyone, and welcome. Today, we're going to talk about something that sounds kind of nerdy, but is actually the secret code behind, well, everything you do online. It's called the OSI model. And yeah, I know, the word model sounds a little boring, but stick with me. This thing is the reason you can binge watch shows, dominate in online games, or fire off memes in seconds. So let's crack this code together. I mean, seriously, have you ever actually stopped to think about it? How does that even work? You send a text and boom, it's halfway across the world in less time than it takes to blink. Or when you're gaming, how does every single move you make get to the server and back so fast? It feels like magic, right? Well, it's not, but honestly, it's the next best thing. Well, it turns out there's this secret, like a 7-step rule book that every single bit of your data has to follow. No exceptions. So today, we're gonna be digital detectives. We're gonna decode this thing together, step by step, layer by layer. And trust me, by the end of this, you'll never look at the internet the same way again. Okay, so let's get into it. Before we jump into decoding all 7 of those steps, we first have to ask, what even is this rulebook? And why does it exist in the first place? So the OSI model, which stands for Open Systems Interconnection, by the way, it's kind of like a universal translator for computers. You have to remember, back in the 80s when this was created, every company was making devices that spoke their own totally different language. Imagine trying to have a conversation where one person only speaks Klingon and the other only speaks Elvish. Yeah, total chaos. The OSI model fixed that. It created a universal language so any device from any company can work together. It's basically what stops the internet from just being a bunch of noise. All right, so here's the plan for today. First up, what is this thing? Then we'll look at the theory versus how it actually works in the real world. We'll follow your data on its crazy journey and then break down the 7 layers themselves. We'll even learn some of the lingo, the protocols. And finally, we'll wrap up with why this whole thing even matters. Let's do it. Okay, now this is where things get interesting. Because it turns out there isn't just one model. Nope. There's the official, by-the-book version, the one you'd learn about in school. But then there's the one the internet actually runs on. So yeah, let's figure out what's going on there. So here's the scoop. The classic 7-layer OSI model, that's the theory. It's the ideal, perfect world concept that explains every single little job that needs to get done. It's awesome for learning. But in practice, the real world is a bit messier. The internet we actually use today runs on something called the TCP/IP model. It's more practical, it's faster, and it basically takes a few of those 7 layers and squishes them together. So think of it this way. The OSI model is the super detailed architect's blueprint. The TCP/IP model is the actual building that got built from it. You study the blueprint to understand why the building stands up. Okay, so how does this whole thing work in simple terms? Let's forget all the jargon for a minute, and let's just imagine what happens when you send something and follow it on its epic journey from your screen out into the wild. The easiest way to think about it is like sending a letter, right? First, you write the letter. That's your actual data, your message. Then, you have to put it in an envelope, which is kind of like packaging the data. After that, you write the address on the outside. That's the routing information, telling it where to go. And finally, you give it to the postman to actually send it over the wires. That's really it. When your data is sent, it goes down through the layers, just like that. And when it's received, it goes back up in reverse, as your friend opens the envelope and reads the letter. Or, hey, here's another one. Think about building a burger. Seriously. Each layer adds a new ingredient. You start with the message. That's your patty. Then, as it goes down the line, one layer adds the cheese, another adds the lettuce, another adds the sauce, all the way down to the bottom bun. Each layer adds its own little wrapper or instruction. You need all of them to deliver that perfect burger. It's the same exact idea for your data. All right, you ready? It's time for the main event. Let's finally break down these 7 layers of magic. We're gonna go from top to bottom, starting with the one you actually see and interact with every day. Okay, layer 7, the application layer. This one's easy because it's the one you actually use. It's your web browser, it's your email client, it's the game you're playing. It's basically the window to the network. This is where you make the decision, hey, I want to send this message, or I want to watch this video. Moving on down to layer 6, the presentation layer. This layer is basically the network's universal translator. Its whole job is to format the data so the other computer can actually understand it. You know, it handles stuff like converting text, compressing images, and even encrypting the data. Think of it as putting your message into a secret code that only the right person can read. Then we've got layer 5, the session layer. This is the conversation manager. Its job is to open, maintain, and then close the communication channel between two devices. It's the thing that asks, hey, are we still talking? Good, let's keep this line open. Then when you're done, it hangs up the call. Simple as that. Next is layer 4, the transport layer. I like to think of this as the quality control director. It takes your big chunk of data and breaks it up into smaller pieces, or packets. And crucially, it makes sure they all arrive correctly. It's like a postman who numbers each package so that if one gets lost, he knows which one is missing and can ask for it again. Okay, layer 3, the network layer. This is the GPS of the internet, plain and simple. This layer is responsible for figuring out the best physical path for the data to travel. It's the one that adds the IP address, the destination, and then chooses the exact route your data is going to take across the entire network. Almost there. Layer 2 is the data link layer. Now, if the network layer is the GPS for the whole trip, this layer is more like the local traffic cop. It only cares about getting the data from one device to the very next device on the same local network. So from your computer to your router, for example. It adds something called a MAC address and does some basic error checking for that one little hop. And finally, we hit rock bottom, layer 1, the physical layer. This is the actual hardware, the stuff you can touch. We're talking about the cables, the Wi-Fi signals, the fiber optics, the actual highway that the data travels on. This is where all that information gets turned into raw bits, ones and zeros, and sent out as electrical pulses or waves of light. So we have all these layers, right? But how do they talk to each other? How does layer 4 know what to do with the information from layer 5? Well, they follow a strict set of rules. And in networking, these rules are called protocols. Think of it this way. Protocols are the grammar rules for how computers talk. Without grammar, language is just noise, right? Same thing here. Without protocols, you just have a bunch of noise on the network. They're the instructions that make meaningful communication possible. And you've definitely heard of some of these protocols before. At the application layer, you've got things like HTTP for websites or SMTP for email. Down at the transport layer, the big two are TCP, which is super reliable, and UDP, which is super fast. And of course, at the network layer, you have the most famous one of all, IP, the Internet Protocol, which handles all the addressing. Okay, so we've gone through all the layers, we've talked about protocols, but you might still be thinking, why does this matter? This thing was invented in the 80s. And that's a fair question. But the truth is, this blueprint is the reason our modern internet works at all. Because of this layered model, we have a universal standard. It means any tech company can build a new piece of hardware or software, and as long as they follow the rules for their layer, it's going to work with everything else. It also makes troubleshooting way easier. If your internet is down, an engineer can check layer by layer to find the exact problem. Is it the cable? That's layer 1. Is it the IP address? That's layer 3. It provides a clear roadmap that makes the entire internet stable, scalable, and connected. So yeah, the next time you send a meme or jump into an online game, maybe you'll think about its crazy, invisible 7-layer journey across the world. Every single click kicks off this incredible trip through the digital world, all happening in the blink of an eye. Pretty cool, huh? Thanks for digging into this with me.